Okay, this is MAT 175, again, lesson 12. And we're going to take a look at some more graphing rational functions. And here we have a function such as f of x equals to 3x, open parentheses, x minus 1, close that. And then we also have here 2x squared minus 5x minus 3. Okay, the first thing you want to do is you want to factor, because you want to see, are there any common factors that that we need to be concerned about? Because if there are, then we need to cancel them out. So factor out our rational expression. Okay, so this is going to, the numerator, that one's already factored out. So we're already fine with that. So we go ahead and we factor out the denominator. And we're going to get here, we have x and x. And we have a plus and a minus. And this is 2 and 1. And we'll have 1 and 3. And so you want to check your factoring. Okay. And of course, this would be minus 6x and a plus 1x, and that would give us a minus 5x. So that checks. Okay, now we want to see, is there any common factor here that that we can go ahead and find out? No, there isn't. So in this case, all we want to do is just go ahead and find the domain. Okay, and that's all it's asking. All right, so what would the domain, if we're looking at this, 2x plus 1 equals 0 and x minus 3 equals 0, basically, what do we do to find the domain, if that's all we wanted to find? Right, we're just taking the denominator, solve for x, right? And so we get x equals to a negative 1/2 and x equals to 3. Now, there's a difference between whether or not it cancels or not. Here, we will have two asymptotes. One at 1/2, at negative 1/2 rather, and the other one at 3. And so, if we're looking at this from negative infinity to infinity, right, we have all real numbers really except for what? Yeah, negative 1/2 and 3, right? So when we write now as far as set notation goes, you just rewrite what you have here, a set of all values in set x, where x does not equal negative 1/2 and x does not equal to 3. All right, but in here, in interval notation, we're going to have negative infinity, right? And then what? To negative 1/2, open, and then what follows after that? Union, and then what? Yeah, negative 1/2 to 3. All right, good. And then 3 to infinity. Okay, now I noticed on the test that some people, they switched around. They would have put something like negative 1/2, negative infinity. Okay, that's wrong. Okay, so at this point, we need to be, correcting that and moving on with that. Okay, so that's the domain with that. Any questions there? All right, now let's take a look at another one, such as, here we have, we'll call this r of x equals to x squared plus 1x minus 12 over x minus 4. So we want to go ahead and factor that. Okay? So that'll be x and x, right? Our signs are going to be plus and minus, right? And then what are the factors? going to be for 12? 4 and 3, right? And so again, there are nothing that we can cancel here, because you have to cancel the whole factor. Okay, so from here, we want to go ahead and find our intercepts. Okay, and what do we do to find our x-intercepts? Anybody? Yeah, set y equals 0, solve for x. So what are we going to use here? 0 equals to what? Yeah, we just use the numerator, right? Because if we use the denominator just goes to 0 anyways. So we can skip that. And so it's easier if we just go straight to the factored part. Okay, and so we get x plus 4 equals 0, x minus 3 equals 0, and we get x equals to negative 4, and x equals to 3. Okay, so our x-intercepts are negative 4, comma 0, and 3, comma 0. All right, questions with that? Okay, and so now we want to set x equal to 0 and solve for y. So in this case, this would be r of 0, right? And at this point, you can go back to here. It's easier if you go back to the original rational expression, and wherever there's an x, you know there's going to be 0 there. So there's a 0, 0, 0 there for each of these x's. And what's left over when we do that? There's a 0 here, 0 here, 0 here. What's left? Yeah, negative 12 over negative 4, and that cancels. That simplifies to 3. Okay, so now we know we have 0, 3 for our y-intercept. All right, questions with that? So you don't have to go through the whole algebra thing. If you just show r of 0 and then what's left, that'll be fine. All right. All right, now we need our asymptotes. Okay, and let's start with the asymptotes. What do we do here to get our vertical asymptotes? Yeah, solve for the denominator, right? So this would be x minus 4 equals 0, and we get x equals to 4. Okay? And so if you wanted to, you could say the domain is negative infinity to 4, right? And 4 to infinity. Okay, not all the questions are going to ask for domain. Not all the questions are going to ask for, the asymptotes and that. But, I thought I'd just go ahead and cover that. All right, now that's the vertical asymptote. And I'll just abbreviate that. Now for the horizontal asymptote. Okay, and what do we do for that? Basically, this is y equals to what? Well, what are we looking for? Yeah, the powers, right? Our leading terms. Well, here we have an x squared and an x, right? So x squared over x. Well, what does that tell us? Right, our leading term, our exponent, our power, or our exponent, right, for our numerator is greater than our power for our denominator, so there's no horizontal asymptote. So what we have to do is we have to find the oblique asymptote. And how do we do that? Right, we go to long division. So we're going to take the denominator, that's our divisor, and our numerator is inside, x squared plus x minus 12. So this would be x minus 4, and then here we have x squared plus x minus 12. And so we're going to go we have 1, 2 spaces here, so we're going to go 1, 2 spaces. And we want to ask ourselves, what times x? We know that x times x will give us x squared. And then x times minus 4 is a minus 4x. Okay, now what? Yeah, change the signs. Oops, we need to be underneath here, right? X squared minus 4x. And we change the signs. Because we're subtracting, x squares cancel, and we get a 5x minus 12. Now what do? Because that's positive, we put a plus there. Now what are we going to put up here for our quotient? Well, we want something times x to give us 5x. 5, right? So 5 times x, that's 5x. 5 times minus 4, that's a minus 20. Okay, now what? Change the signs. The 5x's cancel. We've got a positive 20 and negative 12. That gives us a what? Positive 8, right? So our oblique asymptote is going to be y equals 2, and we use the quotient, x plus 5. Okay, so that's what we're going to graph. All right, so now it's time for us to put it all together. So we said that we had our vertical asymptote at x equals 4. And we have our intercepts at negative 4, 0, 3, 0. And we have our y-intercept at 0, 3. Okay, so, and we have our oblique asymptote. Okay, so here's negative 4. 1, 2, 3. Here's negative 4. And positive 3. And 0, 3. And we also have a vertical asymptote we said at x equals 2, 4. And our oblique asymptote we said is x plus 5. Now the oblique asymptote, we're going to graph that just like we would graph any linear equation. And we'll just use slope-intercept method. Y equals mx plus b. So where's our y-intercept going to be here at this oblique asymptote? 5. So here's 3, 4, 5. And how much are we going to go up and across? Up 1, across 1. And then we draw our oblique asymptote. This is in our way. We're going to need this. Okay? I'll move this over here. And we're going to extend this because we're going to need that. Okay, so it's obvious by looking at our intercepts, what's our graph going to do? It's going to come up 3, right? Come up to our y-intercept, and then come back down. Okay, we can just look at the intercepts and see that. All right, and then by looking at our table of values, what we're going to get is our graph is going to come up here. And that's our graph. Okay? Now, what happens is students tend to leave this part out. But you can't. That's part of the graph. Okay? Just like you said with your domain, you have here it is. We also have a 4 to infinity. So, we have to include that part in our graph. Okay, so that's our graph there. Any questions with that? All right, and there's one more graph that I wanted to show you. And that's one that has a hole in it. All right, let's say we have this. G of x equals to 5, and in parentheses x plus 4 over x squared plus x minus 12 again. Okay, well, the numerator, that's already factored out, so we don't have to worry about that. So we factor out the denominator, and again, we're going to get x plus 4 and x minus 3. Okay, well, we know that from looking at this, right, this will be x equals to negative 4 and x equals to 3 again. So we know that we're going to have a hole here at negative 4. It's going to be open at negative 4, and we know it's going to be open at 3, right? And so we know that our domain is still going to be x is not, we'll just use set notation this time, x is not negative 4 and x is not 3. We know that. But there's a added little bonus here, and can we cancel anything? Yeah, we can simplify. So if we can simplify, we have to. All right? And so what that does is it affects our asymptotes. So I'm going to go ahead and do the x-intercept here, set the numerator equal to 0, right? And we get the x-intercept is equal to a negative 4. But we also have an asymptote at negative 4. So in that case, what happens is there is no x-intercept here because we end up having, right there, it's undefined. If we put 4 in here, right, or negative 4 in here, what happens? Right here. If we put negative 4 in here, what happens? We get undefined. We get 0, right? We get undefined. So we cannot have an x-intercept there. So in this case, there's no x-intercept because there's a hole there. Okay, so there's a hole in place of that x-intercept. Okay, now the y-intercept, we're going to set x equals 0, right? Solve for y. So this will be g of 0, right? So this will be basically 0 here, 5 times 20, right? That'll be 20 over negative 12. And so that simplifies out to negative 5 over 3. Okay, so that'll be 0, negative, or basically 1 and 2/3. 0, negative 1 and 2/3. So when you go to graph it, and we also have our vertical asymptote, we have a hole, right? This is going to be a hole here because it canceled. This will be a vertical asymptote here. But we have to include both of them in our domain. Okay? So in interval notation, we would still have to write this as negative infinity to negative 4, negative 4 to 3, and 3 to infinity. Okay, we would still have to include those in our domain. Okay, now for the, we have our intercepts, we have our vertical asymptote. Now for our horizontal asymptote, what's that going to be? Y equals to what? Well, see if we look at this as 5x, right? If we look at this as 5x plus 20, right? Now what's our vertical asymptote? Yeah, 5x over x squared. The degree, which ones? So we have 5x, degree of the numerator, over the degree of the denominator. So what is it? Is the degree of the numerator less than, equal to, or greater than? It's less than, right? So this is another reason why I wanted to show you this, because I haven't gone over an example with one like this before. So therefore, our horizontal asymptote must be y equals what? 0. Because our degree of the numerator is less than our degree of the denominator. Okay? So that makes it right on the x-axis. Okay, so here's our graph. We have one asymptote right at y equals 0, right on that x-axis. And the other one we have at, we said 3. Okay, and we also have, we said that our x-intercept at -4 is a hole. Oops, I didn't want to do that. We said that's going to be a hole. And our y-intercept, we said that was -1 2/3. So that's going to be, here's -1, -2, -1 2/3. Be about there. All right, so if we take a look at our calculator and we plug that in, and what we could do is we could just go ahead and use this equation here to plug it in with, the 5x plus 20. So we're going to go to y equals, open parentheses, 5x plus 20, and then close it, divided by open parentheses, and we had x squared plus 1x minus 12, and close that parentheses. And we're going to go to second and graph. There's our vertical asymptote. And so we can see to the left of that, as it gets smaller, it goes -5, -2.5, -1. And so as we get closer to -4, here's -4, and so actually it stays a little bit below -4. It doesn't actually go through 0. So it keeps going closer and closer. It stays negative. So it doesn't actually get, because our asymptote is right at y equals 0. In this case, it does not. I wanted to see if it was going to go right above the horizontal asymptote or below it. So here's -4. So do we see that it's going to ride above the horizontal asymptote or below it as it gets more negative? Well, does it ever become positive? It doesn't. So that means it rides where? Above or below? Below it, right? So here's our, so we know that it doesn't actually cross right at -4. It doesn't cross there. It's actually a little bit below it. So our graph is going to come up, go through the y-intercept. Here at -4, you get your hole here, and it gets closer and closer and closer to that horizontal asymptote, but it does never get to it. Okay? Questions with that? And we want to put arrows on both ends. All right, and so now let's see what it's going to do to the right. of our vertical asymptote. So we're going to take a look at, we can go to second, table set, and go straight to 3. That way we don't have to do all that sliding our cursor over so much. And there it is, it's at 3. So now, is it going to be above or below the horizontal asymptote after 3? Yeah, it's going to be above. All the y values are above. So it's going to stay above. And there's our graph. Okay? Questions with that? All right, so that concludes this lesson.